Okay, so this very interesting and very important chapter of electricity, and I'll be teaching you the second unit of electricity, which talks about electromotive force, EMF, terminal voltage, and internal resistance of a cell. It also tells about a combination of resistors. Now, this is really interesting unit, so I'll read it out for you. We have read in earlier classes that an electric cell has two conductors of suitable material kept in an appropriate electrolyte. We have done in the electrolysis chapter of chemistry that there is this beaker or any other container. It has an electrolyte. It has two electrodes are connected to the terminals of a battery. What happens, the materials kept inside the electrolyte, they separate, they dissociate, or and they go to their specific, or whichever cathode or anode they want to go, they go there. Yes, we remember that. The same happens in a cell. Now you might be thinking that a cell gives out energy. Yes, it gives out voltage. Where is it getting energy from? Now there is a cell. Inside it there is an electrolyte. Inside the electrolyte there are ionic particles. When electricity is passed through them, the ionic particles chemically separate and they go to their respective cathodes or anodes. Due to which the cathode or anode, like cathode has cations and it is negatively charged, and anode has anions and it is positively charged. So this increases their difference in potential between the two electrodes. This forms the difference in potential between the two electrodes. One becomes more charged, like one has more electrons and other has less electrons, right? That happens. Now, because one has more electrons and the other has more electrons, there is a potential difference between them, and then electrons have a tendency to move from uh, to the parts where electrons are not there, just to fulfill it. Although we say that current moves from higher potential to lower potential, where higher potential is seen as the positive end and lower potential is seen as the negative end, and yeah, but that we are talking about conventional current. The electronic current goes from the the negative terminal to the positive terminal, right? Because electrons are highly present in the negative terminal. So because of this potential difference, the electrons have this urge to fill in the positivity that is there in the uh, positive electrode, which is the anode here. Now when electrons go from cathode to anode, they pass through the external circuit. Now this external circuit is our circuit that we see, and whatever is happening inside the cell is something we don't come across. So this is happening, and electrons move from one terminal to other